Alrighty, so let me pull up the homework out of that section, and we'll do one problem out of 4.2. That's a test question, and then hopefully y'all will be able to do the rest. All right, there's your test question. No, there's not your test question. And when it comes up, y'all can do it. A modified roulette wheel has 32 slots. One slot is 0 and the other is 00. The others are numbered 1 through 30. You are placing a bet that the outcome is an even number. So your success is an even number. Your failure is not an even number. Figure out that, figure out the odds against winning, and then we'll give you a dollar amount, and then you figure out what your payoff is. So quiet today. Okay. Either y'all are already done with it or you're meditating, waiting for me to start it. One of the two. I'm probably safe in saying the latter. Alrighty. So, 32 slots. So you know that is your denominator. And this is failure. Probability of failure is the opposite of probability of success. Probability of success is the even numbers. The even numbers are going to be 15 over what? And what is the probability of failure if this is success? Good job. I'm so proud of y'all. So your answer here is 15 out of 32. That would be that number right there. So 15 out of 32 is your answer. And you feel good about yourself. Okay, forget it. I was going to try to make that smaller and move it, but it won't let me. So part 1, or part A, is that. Okay, part B. Find the odds against winning. What are the odds against winning? Well, that's your probability of failure over the probability of success. So that's going to be 17 over 32 multiplied by 32 over what?
15.
So your answer is 17 to 15. And we got that right, believe it or not. This one, nobody should get wrong. Because I told you it's the same number. So if you bet $14, what do you get back? 14. Everybody in here should get C right. Because you don't have to do anything. Will you? No. Somebody will get it wrong. And D. What will you win? What will be the payoff? I'm just going to say the payoff. I'm not even going to look at the word profit. What is the payoff if you bet $14 on those odds? Well, you take 14 bucks and multiply it by 17 over what? Somebody give me that number. What is it? 15.87. So you won what? $1.87. Now, I don't know how much time we spent on this, but usually I explain to people about odds against here. The town of Las Vegas is not in the welfare business. The town of Las Vegas wants your what?
Money.
Money. So they are not going to give you money for coming and playing cards unless the probability is low and the odds are what? High. Okay? Odds against are high. So what you want is you want to play a game that the probability is low and the odds are high. It's kind of like just think of it like a horse race. All right, you go to a horse, what's it called? Track. You go to a track and you got $1,000 you want to blow. All right, so you take $1,000. Should you put it on the horse that is probably going to win? Or should you put it on the horse that's called the dark horse? Well, if you want to win a lot of money, you put it on the horse that's the dark horse and pray for lightning storm or hailstorm or a crash in turn 3 because you want the dark horse, the one that's in the back, to win. If you bet on the dark horse and the dark horse is 50 to 1, that means odds against. And you bet $1,000 and a dark horse wins, then what do you take home? $50,000. Okay? If you bet on the horse that is probably going to win, the odds are probably 2 to 1. And you might win what? 2,000. 2 to 1. trying to explain it here. You're not listening. All right, 2 to 1 means you double it. 50 to 1 means you multiply it times 50. 3 to 1, you triple it. So you go to a horse track. I'll just pull it up right quick. Some of you. I have never been a gambler at all. My biggest thing in gambling is playing the lottery. I went to Las Vegas one time. Not Las Vegas. Yeah, I did go to Las Vegas. We rolled out of the U-Haul place. Did I tell y'all that story? There was about 7 or 8 Marines. We were detached out at 29 Palms, and we decided we were going to go to Las Vegas. Well, the the rent-a-car place would not rent 8 Marines a car, or a station wagon, or a van, or whatever. They would not let us rent a car. So we rented a U-Haul box van. And we put refreshments in that U-Haul box van with no air conditioning in the middle of Las Vegas, Nevada. We about died. The driver was okay. He had air conditioning. But that box was just wood and metal in the middle of the desert. And by the time we got to the hotel, we were pretty much cooked in every which way that you could imagine. We were hot, and we had a lot of refreshments. So we rolled out of that box, and we about died because we were like sweating like crazy. Yes, ma'am. We did lift the thing up a little bit, but that didn't help very much. It was awful. But anyway, we lived through it, but it was awful. The whole point of the story is don't rent a box van to go to Las Vegas. Okay? And do not, if you do put refreshments in it, make sure it's Gatorade, all right, or water. Not anything else. Okay? But anyway, you go to Las Vegas. I went there one time, and I just stuck to the slot machines because I went and played 21 blackjack or whatever it's called. Oh my gosh. You cannot understand what's going on unless you've been sitting there for 5 or 6 hours and you know how the guy that's dealing is going so fast and talking so fast that you're like, yeah. And you don't even know if you won until somebody puts a bunch of chips in front of you. So I just stuck with the slot machines, and I didn't win anything. So, but I was one of those that went in with $200, and when I lost the $200, I came out. I didn't lose my whole paycheck like 3 or 4 of the Marines that was with us. They had to sleep on the floor because they lost all their money the first night. So you gotta be careful when you go to Las Vegas. But anyway, they're not in the welfare business. So my whole gambling experience was not good. So anyway, odds, you can go to racetrack odds, and you can betting on horses for dummies, and it'll pull up and you can read about that, and they'll give you odds, and there we go. See, there's 1 to 9 odds, 2 to 5, and it'll show you, how to do that. But you don't want those odds. You want dadgum 50 to 1. You want, and where's the dark horse? Somewhere there's a dark horse. They might show you. There's dark horse is a name of it, but y'all can read that on your own, which some of you might. I don't know. Racetrack, how to calculate betting odds and payoffs, and talks to you about that. There you go. 2 to 1 odds, but I'm trying to tell you that they're not 2 to 1 odds. Usually there we go. Here we go. The dark horse. There it is. If you bet $12, 50 to 1, you win 102. And there's your odds right there. And but Now, what about cards? Like I said, they are not in the welfare business. If you go to Las Vegas and if you go to a game and the game says everybody's a winner, then you might get a nickel every time you win. But if you go to a game and the pot is up to 31 million, then what's your chances of winning? It's better being hit by a bus. Okay? Because you're not going, the odds against winning are very high. And the probability of winning is very what? Low. And that's the way it is in Las Vegas. The odds against are high, but the probability is low. If the odds against are low and the probability is high, you're going to win a nickel. You're not going to win $1,000 or $1 million. You're going to win a nickel or a dollar or whatever. Thus the saying, nothing is what?
Free.
Nothing is free. All right, and that's the reason I show that problem 2 or 3 times is so you will have it for the test, because there is a couple on there. That's the roulette question. All right, 4.3. We're going to talk about the additive rule and the multiplicative rule. That may be 4.3 and 4.4. I don't know. But just look in your book. And there's 3 videos every day on this. There's the 8 o'clock video, the 11 o'clock video, and this video. And sometimes I do different things. So for the 1 or 2 people that actually watch the videos, that's where you can find different problems. The additive rule, or the addition rule. The addition rule is given or is used whenever you see the word or in a question. Find the probability of this or this. It'll say that the last sentence of the problem will say find the probability of finding this or finding this. And there'll be an or. Now the only rule that you have to remember with the additive rule or the addition rule is look for the overlap. Now this is a Hubertism. I don't care what book you look in, you're not going to see overlap. Okay, that's a Hubertism. Unless it's written by me, which that's not going to happen. Always subtract the overlap. What if there's not overlap? Then if it ain't broke, don't fix it. If you don't have an overlap, you don't have to worry about an overlap. Got it? And what in the world's an overlap? Well, get your highlighters out because we're going to use highlighters today. All you need is 2 different colors. Most of your addition rules will be in the form of a chart. I mean, most of your addition problems will be in the form of a chart or a table. So if you get a problem on the test and it is not in the form of a chart or a table, then you need to get it in the form of a chart or a table. Huh? Oh, you got it? Okay. All right. So what are you talking about here? Well, let's go to example. Because the best way to show this, the addition rule and the multiplicative rule, is to start with an example. So, we will start with an example. I'll just go to your homework. One like your homework. No, I don't want to do that. It's too complicated. Some of these tables are just too complicated. I don't like to use the potheads, so we'll go with the drunkards. All right. There's the table. go ahead and just, you don't have to you don't have to write the question down, just draw the table, because that's all you're concerned with. There you go. I told one class that this morning, and there's a student in the back trying to write every single word down. You don't have to write the words, just write the table. All right? Quit talking about me. Gives me insecureness, and I'll have to go out and lift my truck up to 10 feet. Oh my gosh. I was going down the interstate the other day, and a truck passed me. I was going 70, okay? And a truck passed me going like 110, and it was jacked up. I mean, this thing had to be at least 3 or 4 feet higher than my truck. And it pulled over about 3 miles ahead of me. Evidently something broke or something, I don't know. But he was pulled over in the emergency lane. And that sucker got out, and he was every bit of 4 foot tall. Oh gosh, he was this tall. I mean, he was short. I wanted to take a picture, but I couldn't get my camera out fast enough. And it was a big old truck. I mean, this thing was huge. My truck is big, but my truck is factory, okay? But this truck was ridiculous. And I'm not meaning ridiculous in a good way. I mean ridiculous in a waste of money way. Huh? No, it was a F-250. I know what it was. It was a F-250. About I don't know, 2005 to 2006, somewhere in there. Black, with black tinted windows and chrome all over it and all these lights. But he was pulled over on the side of the road. He wasn't happy either. He was throwing stuff. I don't know what was wrong. Maybe he should slow the dadgum thing down. First of all, a truck that high is top heavy. And you're going down the interstate on mud grips. Mud grips do not grip asphalt very well. And he must have had his girlfriend in there because she had her feet all over the front windshield, so it must have been a girl because guy don't do that. So anyway, he's going down the road at least 90 to 100 miles an hour on a top-heavy vehicle that does not hug the road very well. Not very smart. Anyway, I'm glad he stopped because the way he was driving, it probably would have turned over. What the heck am I looking for? All right, y'all got it written down? Now, the question asked, it says the probability, say like you take these people's social security numbers, you put them on a piece of paper, a little slip of paper, and you put whether the pedestrian is intoxicated or whether the driver is intoxicated. You put all that information on there. And you put all these, the social security number and what they were. And you put it in a box. And you take all of those 900 and, how many? 930, I think. Shake them all up. And they want to know, if you reach in there, what is the probability of you picking a pedestrian was intoxicated or the driver was intoxicated? Can you imagine if the pedestrian is intoxicated and the driver is intoxicated? That is not a good scenario. No, they probably didn't get hurt because usually when the driver's intoxicated and the person's sober, usually the sober person gets hurt worse than the driver. You know why? Because, yeah, that's it. And the sober person is going to get hurt more than the driver. I mean, the intoxicated person. Anyway, so I take my handy-dandy highlighter, and I highlight in yellow one of these guys. So, pedestrian was intoxicated, that's yellow. So, pedestrian, intoxicated, boom. There it is. And then I take my green highlighter, and I highlight the driver was intoxicated. And there is your numbers that you're going to use. Now all of them are over, what's your denominator? 930. So everybody should get that right. Okay, there's your denominator. And now you just write down the numbers that you have highlighted. $51 plus 236 plus 51 plus 55. And you always subtract the overlap. Now, y'all are smart people. What do y'all think the overlap is? Where the two colors, what? Overlap. And that would be what? And you subtract 51. Now, a lot of people say, why don't you just cancel them out? This is the easiest way to show students that have never seen this before. This is the easiest way for students to take hold of it. So, now yes, you can cancel out that 51 in one of these, and that's fine. Please quit sneezing. 51 plus 55 is 100 and what? 6 plus 236 is dang old 342. Somebody help me out. 342 over 930. And somebody tell me what that answer is. 0.37. So your probability of pulling a pedestrian drunk or a drunk driver with just one draw, just pick it out, is going to be 40% or 37%, whatever they tell you to round to. Okay? Question? Y'all remember what I told y'all about using your phone in class? Y'all remember me telling y'all that? Okay, I have 3 degrees. I'm not stupid. I know the difference between you using your phone as a calculator and you being on Facebook and being texting. When you come up to me and ask me a question, and I start texting while you are asking me a question, what is that? Then why do y'all do it while I'm talking? I try to be nice and I try to be lenient, but y'all don't want that. Y'all want me to be an asshole. Why? I don't understand. And that's all I'm going to say.
If you're referring to me, I'm using...
I'm not referring to you, Miss Wilson.
Okay, all right. So my thing is...
Now, did I ask anybody to say anything? Miss Wilson, you were using the calculator.
Okay.
I could tell you were using the calculator because you wasn't using thumbs. When do people use thumbs? When they're texting. You usually use your finger when you're using the calculator. Yes?
Problem. Why do you have 51 files?
Because you count up all of the numbers that you overlap. How did that happen? Anyway. Did I change the... Oh, that's the question. Hold on. Back up. Let me go back to number... There. When I highlighted these two, it changed the numbers, okay? Because we evidently... That's 61. Was it 61 or 51?
51.
Okay. This was 51. The green, there's 2 numbers with the green, and there's 2 numbers with the yellow. And then you subtract the overlap. Now, the book explains not to duplicate. Well, that's too complicated for somebody that has never seen this before. So I just tell people to do this, and find an overlap, and if there's an overlap, always what? Subtract. Okay? Question. All right, the next one. I'd like to find one that there's no overlap. But, all right. This one is correct dosage and wrong dosage of a doctor or whatever. And on the medication, you have a concentration label and a ratio label. And in other words, they tell you how you're supposed to give the dosage. So the question is, what is the probability that a physician calculated the dose correctly? That is not an overlap. It's not the additive rule, because you don't have an or. All it is find the probability. So you take your handy-dandy highlighter and you highlight what they're asking for. Physicians calculated the dose correctly. Where is the dose correctly? It's right here. So your probability of the dose correctly is equal to 19 over whatever the total is. Well, the total is 19 plus 19, which is what? 38. So what's the probability of them getting the dosage right? If you're a patient, is that a good probability? No. You at least want a 0.9. I would want a 0.9 unless they're giving away morphine. Or something good, like, what's that stuff they give you when you pull your teeth out?
Lortab?
Yeah, Lortab. Those are good stuff. That's good stuff. I got my tooth pulled, my wisdom teeth. They came in straight, of course. So I didn't get them cut out. So about 10 years ago, I cracked my bottom 2 wisdom teeth. And I had to have them pulled out. Or cut out, whatever. So they cut them out, and they gave me these pills. Well, I never have been put to sleep. Never have I been put to sleep. And that doctor said, so you like to teach and blah, blah. He was talking to me, and they had an IV in me, and he said, okay, now I'm going to give you this, and I want you to count to 10 backwards. And I can't remember what he said, but I said, yeah, whatever. Like it's going to put me out. Because I've never been put to sleep. Buddy, I looked at my heart rate, and I looked at it, and I got to about 7. And that was all I could remember. And I didn't wake up until I was home. That was some of the best stuff I ever had, whatever it was. And then they gave me those Lortabs, and that's some of the best sleep I've ever had. And I can tell why people sell Lortabs on the street. These things are good. I can see why people pop them like M&Ms. I want to go to sleep. 0.5 is not good. Now, the next question they're going to ask, they're probably going to get you to do an overlap. So let's look. And put 0.5. Is that probability as high as it should be? No, it is not. No, one would want this probability to be very high. Yes. Well, whatever. I would want it to be very high. I don't care what the probability is. I want it to be high. Anyway, they go into the next one. Next one, they're going to ask you, what is the probability of a wrong dosage?
Same.
Okay. Now, in this case, it is the same. But in other problems, you don't calculate the other one. You use the what? You use the complement. Now, a complement is not, Miss Poland, you look very nice today. That's not the complement we're talking about. The complement we're talking about is more of a noun. All right? What are you talking about? The complement is what makes up the whole. Let's say there's 20 people in this class. And 15 are female. What's the complement?
5.
5 or what? Other. Okay? That's the complement. The complement is the other number that makes up the whole. Now the whole can be 1, as in probability, or the whole can be a sample set, like 22 students. It depends on how the question is worded and contexted. In other words, there is a problem that you will see in homework and test if they still have it. And it talks about the ratings of a TV show. And they say, what is the probability? And let's say they do 9 homes. They go into 9 homes, and and you got to find the probability that 1 or more watch this television show. And you find the probability of 1 or more, which would be 1 to what? 9. And you find that probability, and that probability is 0.93. All right? The next question they ask you is to find the probability of nobody watching the TV show. Well, if you've got 9 homes, and this is 1 to 9, what would be the answer to 0? 0.07. And the way you know that is because what's 1 or more? 1, 2, 3, 4, 5, 6, 7, 8, 9. What's the only number that's not represented? 0. So if the probability of 1 or more is 0.93, then what's the probability of the only number not showing? 1 minus 0.93 is 0.07. It's the complement of 1. In other words, what's 93 cents and 7 cents? $1. 1. Now here, the probability is the complement. Here, the subset or the sample set is the complement. It all depends on what they're asking. The complement of 65 cents to $1 is what? 35 cents. The complement of true is what?
False.
False. The complement of black
White.
is white. The complement of male is female. Now that is a set of 1. But in a class of 20, if you have 15 female, the complement of 15 female is 5 male. So you have to think of the opposite. Now, what does it have to do with the question? Well, this question, we found the probability of 19 over 38 is 0.5. So what is the probability of the doctor not giving the right dosage? 0.5. What would you want that one to be? You want it to be low. You don't want it to be high. And they're going to ask you that type of question on a different problem. Do these have overlap? No, because you found this one, and then you found this one. Now you didn't calculate this one because you already knew this one. Next question. I had a student in my 110 that stayed after class because I had like an hour before my next class in Math 110, and they stayed. She said, "Let me do it on the board." She got up, the board was still up. She got on that board for about 10 seconds, and she threw the pencil down and said, "I can't do this." I said, "Welcome to my world." So she kept hitting this and hitting this, and it wouldn't work, and she had to go back to the little arrow and hit it, and she just threw it down and said, I'm going to write it on the whiteboard." I just thought that was funny. Anyway, this one says, the probability of the correct dosage giving that the, okay, here it is, I'm sorry. Find the percentage of the correct dosage, and then express it. Okay, find the correct dosage here. They're probably gonna ask you other stuff on this one, I don't know. The correct dosage on this one is 17 out of what? 17 out of what? I'm gonna take your word for it. 17 out of 37. So what would the complement of 17 out of 37 be?
20.
20 out of 37 would be not correct. And they'll probably ask you that on the next question, because some of them have 3 or 4 parts. Some of them don't. So 17 out of 37. Oh, decimal. Give me the decimal. Somebody, 3 places. I don't trust you, Miss Baroni, especially when you have both hands over your face. How much? No, it'd be 17 divided by 37. 0.46 even? 460. 460.
It's 35.
It's what?
17 over 35.
Why did y'all tell me 37? Did you tell me 37? Miss Baroni, you're going to fail this class.
I already am.
Okay. Well, I'm going to help you. If you have a 50, I'm going to give you a 37. I'm going to make sure it's on your report card. All right. And it's going to say, right, the student is a loser. For the physician given the bottles labeled with ratio, find the percentage of correct dosage calculation. Well, the percentage of correct dosage calculation is what? What would it be? Well, what did we find to begin? The probability of correct dosage labeled with a concentration of 0.789. This is the probability of correct dosage calculation given the bottle is labeled with ratios. That's this guy. So take your handy dandy highlighter and highlight this guy, or use the complement. You said that this one was 19 over 45 or 35. Well, what's the complement of 19 to 35? How much?
16.
So this one would be 16 over 35, and that would be 0.210 or 0.211. The complement is 0.211. I did 37 again. What did it come out to be? I'm doing something totally wrong on that problem. I don't know what I did wrong. Did I not read the question correctly? Hold on. The probability of a correct dosage calculation given the bottle the label with concentration is 15 and 14 and 4. That's 19 over 35. Now somebody take 19 over 35 and tell me what that is.
0.5428.
Why is it saying 0.789? Okay. The probability of the correct dosage calculation given. Oh. Given the bottle is labeled with concentration. Bottle is labeled with concentration is 15. 15 over 35. What does it come out to be?
0.4285 is what.
2.11.
Okay. Am I going crazy or what?
It's probably crap.
No, I must be missing something. For the physicians, given the bottles labeled with concentration, that's these guys right here, 19. Find the percentage of correct. Somebody take 15 and divide it by 19. Okay. You got to read the first part. Hubert didn't read the first part. Hubert just read this. Okay? I did that on purpose. Okay? I did that to show y'all that you need to read the first part. All right. For the physicians, given the bottles labeled with concentration. These right here. That's 19. Find the percentage that gave the what? The correct dosage. How many out of 19 gave the correct dosage? 15. So that would be 15 over 19. Now, for the physicians given the bottles labeled what? Ratio, that's 16. Find the percentage with the correct dosage. 2 over what? 16 is your second one. They switch gears on me. So that would be 2 over 16. So, let me ask you a question. The probability of the correct dosage with concentration is equal to 0.789, 79%. The percentage of the correct dosage with ratio is equal to point what?
125.
They're going to ask you, what would you rather have? I would rather have my pills if the doctor can't do fractions, which that's what a ratio is. If he can't do fractions, I want him or her to read these because I want them to give me the correct dosage because evidently they can't read fractions. And that's what that means. I hope this isn't real data because that would be very scary if your doctors cannot do fractions. But what is a ratio? A ratio is a fraction. So that means that the directions on the label says give 1/5 of a dose per 100 pounds or whatever the case may be. And the other one says give 1 cc per 100 pounds. And evidently the doctors don't know how to read fractions. Does it appear that either group did better? What does the result suggest about drug labels? It appears that the group given labels with ratios or the group given labels with concentrations perform better. How about concentrations?
Yeah.
Perform better than the correct dose calculations had much greater than probability of the correct dosage than the poor ratios. This result suggests that doctors are stupid. No. That what? Labels with what?
Ratios, concentration ratios.
Are much better than blah, blah, blah. Okay? I haven't done that problem today, so I didn't even know about it. I was doing the one, okay, here's the one I wanted to get to. This is a problem, and it's got a lot of stuff on it, so most of y'all would probably quit and go to the next problem. Why? Because it's got a lot of stuff and you don't want to deal with this one. Well, it's not that big a deal. You just got to use your highlighters and see if there's an overlap. So, the table below summarizes blah, 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 blah. If one of the blah, 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 blah. Does the probability value suggest that refusals are a problem for pollsters? The probability that a randomly selected person refused to answer. So, still not using the additive law, just a probability. How many people were, you got to add all those up. Oh God, this will cause a meltdown. Add them all up. And I'm going to ask 1 or 2 people to agree on it before I put the, because I don't know. I'm not, you can forget me asking you anything. Yes, ma'am. No. That good? What did y'all get? Thank you. the correct total is 1291. So make sure you put that in the denominator. Chances are they're going to ask you several, there's some of these questions that have several parts, and this might be one of them. I don't know. I don't see an A, so chances are it may not be. Now, how many did not answer or refuse to answer? Well, that'll be this whole section right here. So you will add all that up. Is it 200 even? So the probability here is going to be 200 over, what's the other one? No, 1291. So the probability that they refused to answer is equal to 200 over 1291, which is what? Give me the three decimal places. I'm sorry, what? 015.
Ooh, got conflict.
Be quiet.
They have conflict.
You're not allowed to talk anymore.
That's not right.
Y'all set me up.
.154 or
0.154.
155 to just get around there.
Okay, I'm just going to borrow somebody's calculator next time. 0.15. I don't trust anybody.
If there's a 9 next to the 4, would you
Yes,
up it
155.
That's what I'm asking you. Wouldn't
And
you do that?
I thought I could trust you. I thought I could.
I didn't realize it was sorry.
0.155. There. Now, what have I said? What about the people that responded? Well, please don't go through and add all these up, because it would be 0.845. It would be the complement. Right?
Right.
Check it. 845 should be it. Unless I can add. So if I did the refuse, what's the opposite of refuse to answer?
No, respond.
Not refuse to answer or respond. That's equal to 1,091 over 1,291, which is equal to 0.845. Y'all check my subtraction there. And please do not go through and add all these up, because you don't have to. You just take the complement here, which gives you the complement here. And if y'all have told me the truth, we'll get it right. Some people can't tell the truth in this class, Ms. Baroni. Lost my trust. Does the probability value suggest that refusals are a problem for pollsters? Well, 200 out of 12. Wasn't it 1,200? 1,291? I would say no. But it all depends if you want 100% versus 80%. I would say if I sent out 1,200 surveys and I got 800 back or 1,000 back, would I be happy? Yeah, I would be happy. But it all depends. I think that's a very vague. Question. But I would say, problem for pollsters, I would say no. No, the remaining sample is still. I would say no D, but I'd probably get it wrong. I did. No. Here. Yes, a high refusal rate results in a sample that I don't see how you could call 0.1%. The only way I could see they call it 0.1% is it's greater than 5%. Where did the 5% come from? The empirical rule. What's there in here? 5%. And anything over 5% in probability and statistics is not good enough. So that's where they're getting. And what do we have? Instead of 5 cents on this problem, we got 16 cents. And they're saying that that's too high. I'm sorry, if you send out 1,000, if you send out 1,291, you'd be lucky if you get 1,000 back. You're gonna be extremely lucky, unless you have controlled variables like you don't get all your points on a test if you don't return the survey that I give you today. That would be 100%. Well, 95%, because you'll have somebody with 5 dead grandmothers. So, always. Huh?
That's gonna go through some points for the test?
Yeah, I already had, you missed it. I've already done it. I've already passed it out. You didn't hear a word I said. I said it would be like. And y'all wonder why I get irritated.
I'm sleepy.
Yeah, I'm Hubert. Next problem. What?
But he ain't funny though.
What do you mean a dad joke? I am a dad.
What?
I am a dad.
No,
Yeah.
that's
The mother joke is, where is it at? Behind that. That's the mother joke. Huh? Well, it's grammatical error. All right, is this one that we just did? Let's go to, I want to go to one with parts, but I don't know. Okay, here's one where you don't have a chart. And most of you will do what? Skip it and go to the next problem. Because this is too much work. So I'll blow it up for you. I can't blow it up very much, but I'll blow it up as much as I can. I'll read it to you because it's going to take 5 minutes for that thing to turn back on. I suck. Pollsters are concerned about declining levels of cooperation among persons contacted in surveys. A pollster contacts, y'all ready? 84 people, 84, in the 18 to 21 bracket, and finds that 72 of them respond and 12 refuse to respond. So 84 people in the 18 to 21 bracket, 72 respond, 12 refuse to respond. 72 respond, 12 refuse to respond. Is it up yet? No. 290 people in the 22 to 29 age bracket, 290. 278 respond, and 12 refuse to respond. It's on. Now it's on. There you go. Find the probability of getting someone in the 22 to 29 age bracket. What's that word? Or someone. So you're going to have to use the additive rule. So there's your or right there. So make a table. And you're going to make a table, and it's going to look like this. 18, 21, and 22 to 29. And these are responded, and these are refused to respond. In the 18 to 21 age bracket, 72 responded and 12 refused to respond. In the 22 to 29, 278 responded and 12 refused. They want to know what is the probability of someone in the 22 to 29 age bracket, or what? Refuse to respond.
So it doesn't mean like just people refuse to respond in the 22
if you put all these people's social security numbers and what they did on a piece of paper, put them all in one box, they want to know what is the probability of getting this one or this one. You're going to pull one name out or one piece of paper out. And they want to know what the probability of getting one of these guys or one of these guys. So how many is the whole thing? Somebody add up.
302
302.
over 370.
274.
The total is 374. Okay. The total is your 374. That's your total. And then we've got 278 plus 12. That's the green. So 278 plus 12 plus, and then the yellow is 12 plus 12. And then we're going to minus the overlap. And what's the overlap? 12. And, of course, that guy will cancel with one of those, and you're left with 278, dang old 290, dang old 302. So we got 302 over, thank you, 374, and somebody give me that number.
Wait, 804, sorry.
I know who's trying to set me up now. 0.807.
Yes.
So you got an 81% chance of that slip of paper that you pull out of that box. You got an 81% chance that it's a 22 to 29-year-old or it's a person that did not respond. And I know you could care less about that, but if you're sending out these things, if you're sending out, and be very thankful because the math department right now is working on a across-the-board project for each Math 120 class. So,
We will not be part of.
yeah, in other words, like next fall, it's going to be. So, and I said, whatever, because all it's going to be is it's going to be a hassle for everybody to do. But anyway, in the future, Math 120, you will be sending out stuff, or you'll be going out in the parking lot counting cars, or you'll be going out and asking people if they're in the Marlboro Club, or whatever the project you come up with is. You're going to be going out and doing some of this stuff, and if you send out a survey or give out a survey amongst people in your classes, that's if you take 5 classes, that's 150 people. So, you know, you might want to get some of this stuff back. So, it does matter. Depends on if you're doing it or not. And the answer is 0.807. So we'll type that in and see if we feel good about ourselves. 0.807, and we feel good about ourselves. Now, what if I just asked you to find the probability of 18 to 21? Well, then 18 to 21 would be, what, 84 over 374. So there's no overlap there if I just asked you one probability. Sometimes there'll be several of these classes. In the previous problem, this one? Yeah. What if I asked you to find the probability of 18 to 21 or 40 to 49? Would there be an overlap? No. So you don't have to subtract. You just do the probability of these. That would be what? 94? 94 and 172. And that'd be 94 plus 172 over however many the denominator is. 12, 91, whatever it was. Okay, so if there's no overlap, then you just add and put over the denominator. If it's just asking you for a probability, then you just do whichever probability. If I just want the probability of 18 to 21, then that would be 79 plus it'd be 94 over 1291, or whatever that total is. So the only time you need to worry about an overlap is when there is a overlap. And that is the additive rule. That's the addition rule. Question. Remember, on any type of probability problem, always remember the complement. Because the complement, you don't need to calculate the other side, you just need to calculate -1 if you're talking about the probability. If you're talking about the sample set, then it would be 1291 minus whatever this bottom came out to be. And it's 10 something. Okay, so remember that because that'll cost you a lot of time on a test if you're going over and recalculating the other side, which all you got to do is subtract it from the whole. Okay? Question? I don't do pothead jokes. I don't do those. Y'all can do them if you want to, but I don't do them. All right, look at that one. Or did I do that one? I didn't do that one. That's 18. Go ahead and look at those. Look at that one while I do the roll. This talks about refuse to answer questions. And I'll pull up the roll. I think I froze it. Okay, Miss Bannister is not here. Miss Baroni is here. Miss Barrington is here. Mr. Carpenter, not here. Sharping, thought I saw you. Dawson is here. Desai is here. Franks is here. Gray is here. Hunsinger is here. I know Melissa's here. Miss Jones Taylor. Okay, she's here. Kern was here. She's still here. I mean, Kurtz. Yeah, Kurtz is here. I get y'all mixed up sometimes. Y'all's last name starts with K. Kurtz, Kearns is here. Marshall.
Here.
Where are you? Okay. Mayfield. Morgan. Y'all loud ones I can't keep. Mullen is here, right? Oliver is here, right?
Yep.
Poland is here. Robinson is here. I'm learning some of y'all's names. Roller.
Here.
Another loud one. Smith. Sammons is here. Smith. Tollison. Turner. Another loud one. Whitman. Wilmerine came by, and Wilson is here. All right, this question. What time's class over? 12:35, right? Okay. All right, this question. The probability that randomly selecting blah, blah, blah refused to answer the question or is below 22. So get your handy dandy highlighters out. And I'm going to highlight, don't forget, refuse to answer. And find the that, or is below 22, or what? Oh my gosh, you got two overlaps. What's the total of everything?
49.
I'm not sorry.
1249.
1249. And now you just add up all the numbers. 75 plus 12 plus 12 plus 21 plus 34 plus 27 plus 36 plus 58 plus 58 plus 204. And then minus the overlap. Well, we're going to add the two overlaps. 12 plus 58 is dang old what, 70? So that 70 is going to cancel with one of the 58s and one of the 12s. And now you just add up what's left, and what do you get? I'm sorry, what?
188. That's what I got.
I'm sorry, I didn't hear that. Anybody else?
188.
Okay, are you sure? Don't try to regain my trust. You can forget it. 188, I'm just picking on you. 1249, and somebody give me that. And you type that in, and hopefully y'all told me correctly.
Oh, 150.
You know, I'm going to pull a female. I'm not going to trust any of y'all.
Try it.
I'm not going to trust. Y'all have ruined my trust. So I'm not going to trust y'all anymore. Oh, forget it.
Sorry.
We all suck. Okay, somebody didn't add up the dadgum correct numbers.
I got the same numbers.
Well, the correct answer is .374.
Hey, that's what I got.
Okay, what was your numbers?
Um,
What was the two numbers? 188 over 1249? What was it?
I don't know. I know it was
67 over 1249.
Okay, so 188. Somebody didn't add up the numbers correctly. Thanks a lot, y'all. Okay. Okay, for those watching this video, this class sucks.